Hey, what's up guys? Jeremy here from RoboDK. Welcome to another video of the series covering the features of our Fusion 360 plugin. For this tutorial, we will talk about laser cutting. We will do this example together. A Motoman robot cutting holes in this stamped piece of metal. To do that, we will use two different methods. One using the feature extraction method, and another one using the laser cutting features from Fusion 360. Let's see how we can do that. Okay, here's our station. A Motoman MH50-35 equipped with a laser cutting head. And underneath that, a laser cutting table. Note that we have a reference frame called part in the middle of the table. This is where we will import our part. Just make sure that this is the activated reference frame, just like this. Okay, and let's jump to Fusion. Here we have our part. Like I said in the intro, it's a stamped metal part. You can see it if we come a bit closer to the part. You can see this here and that. So let's say that after coming out of the press, we need to cut all those holes with the laser cutter. Programming that by hand will be a very big task. I'm pretty sure that we can do something a bit quicker here. Okay, now we are in the design section of Fusion. And in the toolbar, we have a new tab called Tools. And if we open it, here we have our RoboDK plugin. As usual, it's the same pattern for every plugin we have. The first option is the auto setup. This one will bring the part and the path inside RoboDK. But for this example, I prefer doing that in two steps. I'll start by loading the part. Let's do that. And switch to RoboDK. The part was imported in the activated reference frame. But as you can see, it's not in the right orientation. This is simply caused by the orientation in which the part was designed in Fusion. It's not a big deal, and we can fix that in a few seconds. Just double click the part, more options, and rotate it 90 degrees around the x-axis. Then apply move. Now we modified the orientation of the part inside RoboDK. So now let's go back to Fusion. The RoboDK plugin has another feature that will help us import that cutting path to RoboDK. The Load Curves one. If we select it, this little window will pop up. The first tab asks you to select points, curves, and faces. We will start by selecting some curves. Let's only start with the big 4 circles. So this one, I'm selecting the edge of the circles, and that will become the path. And this one, perfect. Now I need to give RoboDK an orientation for the robot tool. To do that, select faces, and then select faces you wish the tool to be normal to. In this case, I'll select this one. Once we're done, we can go in basic settings. I will uncheck the Use Fusion theme. I prefer keeping RoboDK in its default behavior, but this is just a personal choice. I will give a name to this path, so let's call it path 1, and I want to export this path on the part reference frame we have in our station. And for the tutorial purposes, I only want to update the program, not simulate it. That would skip some steps that I really want to show you inside RoboDK. And finally, for the advanced settings, I won't change anything. I just want to tell you that the linear tolerance will control the number of points you will send to RoboDK. The smaller this number is, the higher the number of points, and therefore the precision of the path. Now click OK, and back to RoboDK. So here we have the path that was imported, but in a similar way as for the part, the orientation is wrong. So we need to do the exact same thing as we did for the part. Double click the path in the station tree, more options, rotate 90 degrees around X, and apply move. Now we can open the curve follow project that was automatically created when we imported the path. And if we update, the path should be at the right place. But as you can see, we only have one of our 4 circles. So we need to fix that. But first, make sure that the robot, the reference frame, and the tools are the right one for this project, if you have more than one in your station, obviously. Now select curve, and now select the other parts of the path. So this one, and the last one here. Remember that you can always switch the direction of the path by right-clicking on it. And after that, switch Sense. Now we can click Done. We have all our path. Okay, now that everything is there, we can see that we have an approach and a retract movements that are a bit abusive in terms of length. So we will reduce those values here. 100mm is the default value. 25mm will be enough here. So same thing for the retract. Okay, perfect. Now we can update the whole program and simulate it. Okay, it looks pretty good. But in fact, there is a big problem with what we just created. We didn't take into account the radius of the laser. So by cutting right on the edge, we are cutting too much material. So we actually need to cut a little bit inside so that the final dimensions of the holes are right. This is something we can fix, but inside Fusion. So, okay, go back to Fusion. I'll start by creating a sketch here. I'll create one circle. I'll select the circle, and I'll use the offset feature to create a new path inside of the circle. Okay, let's say that the diameter of the laser beam is 2mm, which means that the radius is 1. So let's set our offset at 1mm. Let's do the same for the other 3 circles. So create a sketch, select the circle, and then offset. Okay. This one too. Okay, this should be good. Okay, now that we have done that, we can go back to the Load Curves feature from the RoboDK plugin. This time, instead of selecting the edges, I'll select the sketches. And don't forget to select the face afterwards. This is also required here to give RoboDK an orientation for our tool. So remember, it will always be normal to the surface you selected. Perfect. Let's change the name for Path 2 and click OK to import it. After a few seconds, it should appear inside RoboDK. The time will highly depend on the complexity of the part and the power of your computer. Now we can modify the orientation of Path 2. Again, more options. And the 90 degrees rotation. Okay. If we come closer, we can see the difference between the 2 paths. Don't forget that you can improve the smoothness of the path by reducing the value of the linear tolerance in the advanced settings of the Fusion plugin. We will delete the first path we created. And okay, let's open the curve follow project. Update to make sure that the path is in the right position. And we can select the other circles. So select curves and select the other circles. Okay, perfect. Click done. Let's reduce the size of the approach and the retract movements. Again, 25mm is enough. Same for the retract. Now let's update and simulate. This looks pretty good again. Perfect. So we could do the exact same thing for all the holes in this part. And by the way, this would also work for a 3D part. So let's say that this 10th part, instead of being just a flat one, it could be a very curved one. And we could follow a laser cutting path always while being normal to the surface. The only difference is that you would need to be very careful selecting meaningful surface so that the orientation of the tool stays normal to the cutting surface. This way of building a laser cutting program works for our Fusion 360 plugin, but it also works for all our CAD plugin. We could stop this tutorial here and everything would be just fine. But there's still something else to see. I promised you a second method. If we go back to Fusion, I will hide the sketches we did before. And instead of sticking to the design section, we go to the manufacture one. In the toolbar, you can see a cutting feature, a 2D cutting feature to be more precise. I'll use it. So first, they ask for a tool. I'll just use this 1mm wide cutter. Perfect. I'll then select the geometries I want to cut. Make sure that the cut is on the right side of the path. For this last example, I'll select all the holes. It's gonna take some time, so I will fast forward the recording a bit. Once everything is selected, you can click OK. We can simulate this path. Okay, perfect. All the holes seems to be covered. In the setup, make sure that you are using the same origin as the model. This way, it will be exported at the right position. Now we can transfer that directly to RoboDK. So Tools and Load Cam Project in RoboDK. Now we can go to RoboDK. The loading of a program like that should take seconds. Now we can delete the previous curve follow project we created and its path. Now we have the laser cutting part machining project, and we already see the green path on top of the part. I can open it, update, and then simulate. I can hide the normal so that we can see better. Okay, it looks pretty good. And now the only thing we need to manage is the program events. So let's open it. Here we are not doing a machining project with a spindle, multiple tools, or some specific RPM to reach. So therefore, the first 3 text boxes can be erased. After that, we want the laser to be activated when the path starts, and we want it to be stopped when the path finishes. So we will activate those, and we will enter the laser on here and laser off here. Okay, now we can update again. Just under the machining project, we have the program related to it. So if I right click on generate robot program, this new window will appear with the program post-processed for the Motoman controller. At first, we have all the points, and there's a bunch of points to reach. And then we have all the moves. Again, there's a lot of moves to do. And just here, we have our laser on subprogram. So somewhere in the controller, there should be a subprogram called laser on that activates the laser. In other words, you guys need to integrate the laser to your robotic system. Okay, that's pretty much everything for today's video. I really hope you enjoyed it. If you did, subscribe to our channel. This way you will keep yourself updated with the newest RoboDK features.